Hello friends, in this video tutorial we are going to learn about probability. So you might have got used to this term by now, I suppose, from your earlier classes, but we'll deal more into the axiomatic approach of probability in this particular video tutorial. So before moving on to the concepts of probability, we'll see uh, I would like you to revise the general concepts of permutation and combination, which I call PNC for short. So do look at them because they will be extremely helpful in solving some of the uh, questions in this particular probability chapter. So let's now move to the concepts of probability. So the first concept is that of the random experiments. An experiment is called random experiment if it satisfies these particular certain conditions. That is, it has more than one possible outcome. It may be two or three more than that, and it is not possible to predict the outcome in advance. It may be somewhat probable that this particular outcome may come, but it's not always certain that it may show up. Next, we look into another terminology, which is outcome. So the possible result of the random experiment is called the outcome. Next thing is the sample space that contains all the possible outcomes of a particular random experiment, and each element is called the sample point. So this particular term is very important and very easy to write. Generally, the question focuses on writing the sample space and choosing the sample points of the required experiment. So next thing, this is the only thing which takes time in this particular chapter, and if you grasp this concept, it's just very easy for you to get all the probability questions correct. So this particular term means event, and what event means, basically it's a it's the subset of the sample space S. And this particular subset is chosen according to our requirement. That is, the subset is chosen of the property which we specify in our probability question. So after we have looked into what are events, let's see what about let's learn about the occurrence of event. The event is said to be occurred if that favored subset, if any point of that particular subset comes as the outcome of the experiment. So here we can have two types of events. We could have certain events which are impossible. Let's say if we are tossing a coin, so we could not have the coin to turn up 1 or say 2, because it has only two sides, that says head or tail. So it the when we in the experiment of tossing a coin, the probability of obtaining a 1 is impossible. So basically it'll have the event cannot occur, so it's an impossible event. And let's consider another experiment. Let's say if we choose uh, if we are throwing a dice, then the event that occurring of a number which is less than 7 is a sure event, because all the numbers on die are always less than 7. So this particular event will be sure in this particular experiment. We'll generally be dealing with this particular types of event, that is simple event, which are neither impossible nor sure. This is a bit, as you can see from the particular name, a compound event. So in this particular event series, we basically have two or more smaller events taking place. We'll look into this through some questions. So before moving on to solving some questions, we need some of the basic terms to relate the different events. So first one is the mutually exclusive event. which says that if events cannot occur simultaneously, that is, let's say if we toss a coin, the occurrence of head and tail are mutually exclusive. That is, if head occurs in a particular outcome, then the other is eliminated. That is, a tail cannot occur in that particular outcome. So here we have a different example for a mutually exclusive event. So let's say in the experiment of rolling a die, a sample space is given by 1, 2, 3, 4, 5, 6, which says basically because sample space is equal to the subset, the set of all the possible outcomes of the experiment. And let's have two events. Let's say we have an event A, an odd number appears, and an event B in which an even number appears. So basically these two particular events are mutually exclusive because we cannot have the two events simultaneously. That is, we cannot have a number which is odd and even in the experiment of rolling a die. Next important concept is that of the exhaustive events. Let's say we have events E1, E2, dash dash En. They are said to be exhaustive if at least one of them necessarily occurs whenever the experiment is performed. That says, let's say, for example, we have the same experiment as throwing of a die, and this is the sample space. Then, if we have these three particular events, let's say a number less than 4 appears, a number greater than 2 but less than 5 appears, and the third event as a number greater than 4 appears. So, if we roll a die, that is, do this particular experiment, then it is confirmed, it is sure that any one of this event will occur. Let's say if we roll a die and 3 occurs, then the event B has occurred. So basically these three events are the experiment A, B, C are exhaustive events. Individually they may not be exhaustive. Let's say we have the set the event A and B. These two particular events will not be exhaustive. Only the three set A, B, C will form the exhaustive events, because in the case we have if we choose A, B, then if a number greater than 4 appears, that is, let's say an outcome is 5, then this particular outcome is not contained in these two particular events. These two particular events do not form the exhaustive events. Only these three sets ABC form the exhaustive events. So as I told you in the earlier part or in the starting of the video tutorial, that we are going to look probability through the axiomatic approach. So let's first of all define what axiomatic approach is. So let's say if we have a sample space S containing outcome omega 1, omega 2, omega n, that is, the sample space is set containing omega 1, omega 2, and so on to omega n. It follows from the axiomatic definition of probability that the probability will follow certain properties. So the first property is that the probability of any of the event or the compound of events will lie between 0 and 1 for all the particular events, and the sum of the probabilities of all the events will always be equal to 1. And the third property is for any event A, PA is equal to sigma P omega I, where omega I epsilon A. Next we look on to this particular is a term which is generally used in problems to express a particular property of the events, that says that if the chance of occurring each simple event, that is the sample point in the sample space, is same, then then particular sample points are called equally likely, or we say all the outcomes are equally likely. In that case, if all the events are equally likely, we'll have the probability of each particular outcome as 1 upon the total number of possible outcomes.